Chapter 15. Objects and classes being organized is better than not. In the last chapter, we examined some interesting data holders, structures and records. These are the precursors to the object, which we will look at in this chapter. Perhaps you have heard the term object-oriented programming. If not, you will have a good grasp of what that means by the end of this chapter. In this chapter, the object, classes and objects, public or private, fields, constructors, accessors and modifiers, instantiating an object, calling a method from inside and outside the class. The object. Object is a special term for a type of data structure that encompasses both a data structure and its behavior. This is a departure from all previous holders, which just stored different kinds of data. The object is a more powerful structure because a programmer must consider both what kind of data it will contain and the behavior it will have. When we talk about behavior of an object, we are discussing what kinds of functions it will be able to carry out. So an object is a data structure designed to execute certain kinds of behavior. When you consider an object, you think of two things: what you want to store in the object and what you want the object to be able to do. You write and design programs with an object and its actions in mind. This is a departure from previous considerations where data structures and the actions executed on them were considered separately. We call this focus object-oriented programming. Example: Think of a student object that you might design for a school computer system. You would want the student object to have a storage for a name, address, age, GPA, and so on. And you would want that object to be able to access all of that information as well as modify it. Look at this: string name, address, int age, string GPA, int year of graduation. These are just a few of the possible data fields this object could have. Now let's consider the behavior of the student object. All objects have to be able to load themselves, that is, assign all of their fields some data. We call this constructing the object, or a fancier word, instantiating the object, what I call bringing the object into existence. Once the object has been instantiated, we should be able to both to access its fields, attributes, and also alter them. So that means we are now starting to consider the behavior of the object. We need to write functions that will give us access to these attributes and allow us to modify them. So some of the behavior of the student object would include assigning the name of the student, the address of the student, the age and the GPA, and the year of graduation of the student. But the word behavior suggests that the student object should be able to do something. What if the student object could change its address or update its age or even increase its GPA? These actions would constitute the behavior of the student object. An object together with all the functions, methods that make up its behavior is known as a class. You might have heard that word before. Hereafter we will use the terms method and function interchangeably. Object-oriented programming. Object-oriented programming is a tidy way of designing a program and keeping everything organized. If you always have to consider an object and what it can do, you are keeping the object as the focus of your program. Programs and languages for that matter that do not include objects can become unruly and disorganized because the programs are dependent on the programmer's design, whatever that may be. Keep in mind that computer science is a relatively young discipline compared to mathematics, chemistry, or English literature, to name a few examples. Programmers have learned to become more organized through the development of languages that allowed them a systematic way to be organized. The original BASIC language, recall that the name was originally an acronym, did not allow a programmer to block off work, even into a function. Imagine a program without functions and how unruly that program might be. The advent of objects and classes has allowed programmers to be even more organized than before, since they cannot consider functions or behavior separate from the data structure object involved. If you keep this in mind as you study objects and learn how to program with them, you will start to see the benefits of this perspective. Privacy of the object. One of the first rules about handling objects is getting used to some of the restrictions in working with them. First of all, you have to create a place where the object lives, so to speak. This is the class. At the top of the declaration of a class is the word public. See Figure 15.1. Figure 15.1. Notice that the word private is used before each attribute is declared. Braces also enclose all the fields and methods. Public class student, opening brace, private string name, private initial age, private string address, private string GPA, private int year of graduation, public student, constructors here, opening brace, closing brace, public int get age, accessors here, opening brace, closing brace, dot, modifiers here, closing brace, class definitions end here. This is to notify other classes that they will have access to the objects in the class. After this declaration, the attributes of the of the object are listed next. Usually, these attributes are private. One reason attributes of an object are private is because of the general rule that programmers try to protect objects from being inadvertently modified by other methods or functions within the program. The private tags used here mean that outside of the class, no one can touch these private attributes. Consider our student object. We would like a student's name, address, age, and GPA to be kept private. If another part of the program needs this information, we will force it to call a method to get that information rather than being able to know the GPA right away. Figure 15.1 is an example of a class definition for a structure for a student. The class. The class consists of the fields of the object followed by the constructors, the accessors, and the modifiers. Constructors. At the top of the class following the attribute listing, at the top of the attribute listings are the constructors. These are the special functions that assign all the data fields of an object. You will notice that they have a heading that has no return type. This is the best way to recognize a constructor. The syntax of a construction heading is as follows: public object name, parameter list if necessary. The main purpose of the constructor is to bring the object into existence and to assign all its data fields. There are different types of constructors: default constructors and copy constructors. The examples that follow are written in Java, since it's a fully object-oriented language. It's easier to view these examples in Java because it was designed to handle objects. Default constructors. Default constructors load all the fields of an object with the default values. So all integer and number fields would be assigned 0 and any strings would be assigned the null value. All classes are programmed to have a default constructor whether the programmer provides one or not. A default constructor is a safeguard against a class that did not have its own constructor. Here is a default constructor. Public student, opening brace, name equals quotation marks, address equals quotation marks, GPA equals 0.0, age is equal to 0, year of graduation equals 0, closing brace. Other constructors. Other constructors will assign the fields of the object with data passed in through the parameter list. Public student string name 1, address 1, double GPA, int age. Opening brace, name equals name 1, GPA equals GPA 1, address equals address 1, year of graduation equals YOG, age equals age 1, closing brace. Each field has been assigned with values that were passed in. Notice that the data type match notice that the data types match. It is not necessary to assign all the fields from the parameter list as in the preceding code. Look at the following example. Public student string other name, opening brace, name equals other name. Only other name is passed into the constructor for the name field. The other fields are assigned. GPA equals 3.0. Address equals 15 lakhs per lane, etc. Closing brace. When we call a constructor, we are really instantiating the object. That is, we are bringing the object into existence. Note, in Appendix B, you will see how constructors are handled in C++. Accessors. Methods that access part of an object are called accessors. Here is an example of an accessor. You want to find out a student's age. The way to do that is to write a method function called getAge. If you want to find out a certain student's name, you would write a function called getName. The same goes for finding a student's address or GPA. You would write methods called getAddress and getGPA respectively. Here are examples of two of those methods. String getName, opening brace, return name returns the name of the object that called it, closing brace. Int getAge, opening brace, return age, closing brace. Recall from chapter 8 that functions often return a value to the calling place, otherwise they return no values, and the word void would be used in the function heading. Note, methods that begin with the word get are called get functions because they get information that you need about an object. Modifiers. Methods that alter existing fields of an object are called modifiers. Modifiers allow the programmer to change the values of any of the fields of the object. As a point of organization, there is generally a modifier method for each field of the object. Look at these examples. Void, set name, string other name, opening brace, name equals other name, closing brace. Void set GPA, string other GPA, opening brace, GPA equals other GPA, closing brace. Void set address, string other address, opening brace, address, other address, closing brace. In each of the examples, the return type is void because no values are being passed back to the calling function. Also, each method contains only one statement, an assignment statement. The assignment statement has this form: field, arrow pointing to the left, new value. The field of the object is being assigned the new value that came from the outside, the value being passed into the function as a parameter. When the programmer wants to alter the value of an attribute of the object, she just calls that method and passes in the new value she wants there. Notice how the modifier forces the programmer to keep her hands off the object's fields. That's how the object stays private, in a sense. In the next section, we will talk more about who has direct access to the object. Note: methods that begin with the word set are called set functions because they set or assign the fields of an object after it has been constructed. How an object calls its methods. As we saw in Chapter 11 on strings, objects call their own functions. Function calls are not made separately from an object. An object calls its methods either from within the class or outside of it. Let's start by looking at how an object calls methods from outside the class. Calling from outside the class. Once a class has been defined and given its accessibility, objects can be instantiated and methods can be called. Let's assume all our classes are public so that we can make a call to the object's constructor outside the class but within our program. We will use the student object, which we already defined. Student first student equals new student. The default student has been constructed ... in one line. Get a name for the student. First student dot set name, new name. In this program fragment from Java, first student is instantiated with the default constructor. As we know, the default just assigns 0 and empty strings to any fields of the object. So we call the modifier method to assign first student's name with the name that we get from the user or some other place. Let's examine the call to the default constructor. Student first student equals new student. We use that new word, always present in instantiating an object, and later you will see in working with a pointer. See Chapter 17. Also notice that we called one of the 3 student constructors, and since our parentheses are empty, the compiler will choose the constructor with the empty parameter list as the matching method to execute. Next, let's examine the call made to the modifier method. First student dot set name, new name. Look at the sequence of items: the object name, a period, and the method name in parentheses, with its matching parameters. As we assign all of the other fields of the object first student, notice how each statement matches this model. First student dot set address, new address. First student dot set age, age now. First student dot set GPA, true GPA. First student dot set year of grad, year. The term object-oriented programming becomes more meaningful once you understand that the object initiates all of the action on itself. Also note that there are as many parameters in the call made by the object as are in the method's parameter list. My examples here happen to have only one parameter, but that is just a coincidence. Calling from inside the class. When you make calls to methods within a class, the syntax is simpler. There is an understanding that if you are already inside a class, you go there because some object came into existence. This object is understood to exist, but if one is pressed to give it a name, it's called this. That's right, this. Here is an example. Let's say I have an additional method called isHigherGPA, which will return a Boolean variable of true if the calling object has a higher GPA than the object in the parameter list. It will return false if it will return false otherwise. Here is the code for the method. Boolean is higher GPA, student other student, opening brace. If this dot get GPA is greater than other student dot get GPA, return true, else return false, closing brace. So the important line is the first line of code following the brace. If this dot get GPA is greater than other student dot get GPA, we can see that the same syntax we used when we made a call outside of the class applies here. This object is calling the method by using a period followed by the method's name and the necessary parameters, which are none in this case. As I mentioned previously, you do not have to you do not have to use the word this to make a call. Looking at the same examples, Boolean is higher GPA, student other student. Opening brace. If get GPA is greater than other student dot get GPA, return true, else return false, closing brace. Think of how efficient this call really is when get GPA is called. The compiler knows that the main object must have called it because there is no other object name given. Summary. Object-oriented programming describes a kind of program design where the object initiates all calls and is the center of its behavior. Class syntax was introduced, followed by constructors, accessors, and modifiers, the main methods that are present in a class. A method, which is public, can be accessed outside of its class. The fields of an object should be private to prevent any uncontrolled modification. There are two kinds of constructors, default and normal. Accessors allow the programmer to get at the fields of an object. Modifiers allow the programmer to alter a field of an object after it has been constructed. There are two places where objects called the methods of its class: inside or outside of the class. The syntax is almost the same. The object name, a period, the method name, and any parameters that the method requires. Within the class, the object name, which is always this, is optional.